Hello, everyone. Welcome to the Intent Summit. I am super excited to be here with you today. My name is Alyssa Miller. I am the Business Information Security Officer for S&P Global Ratings. Now, if you find yourself asking what in the world is a Business Information Security Officer or a BESO, good news is we're going to get there. Give me a little time. We're going to talk for a little bit. We're going to share some stories. We're going to have all sorts of fun. But we'll get there, and I'll talk to you about what a BESO is and how a BESO can help you bring security in as a business function. Now, for security researchers, I know that kind of sounds like, wow, that's a really corporate topic, but trust me, we're going to get there. You're going to understand why this applies to each and every one of us in the security community, regardless of what we're doing for our community. Me personally, I've been a hacker all my life. I mean, I was the 12-year-old who bought her own computer, and I used it pretty quickly to hack into online services and so forth. And I've been doing it ever since. I was a programmer. I was a pen tester. I've been through all sorts of different security roles over the last 16 years. So we're going to dive into this. But first, I want to just start by telling you a little bit about my kid. All right. So I've got 3 kids. My youngest was getting ready to drive a couple years ago. And, he comes to me and he wants to get a car. He's going to get his driver's license. He wants his own car. And, he comes to me, he says, hey, I found the car. It's this 2014 Mustang GT. And he's all super excited because it's, it's only $7,000. And of course, imagine the look on his face. We've all been there, right? When I tell him, nah, I don't think you're getting that. I think you're getting this 2007 Toyota Camry instead. He had all these dreams. He wanted to go fast. He wanted the cool car. He wanted it to be awesome. And what did I do? I kind of shut him down. I give up. Sorry, no, you're going to be driving this boring car because it's safe. And I don't know that you would be safe in that Mustang. I want to make sure that you've got something we can trust. And so, we've all been there as kids. You remember what that was like when, your parents didn't really want to buy you the cool, awesome car that all your friends were going to be wowed by, and instead you drove some boring family mobile or something like that. So, I think about this in terms of what do we do as security people? We've got devs, we've got businesses who want to go really fast. They want the cool car. They want all the cool new technologies. And there's security. We stand there and we say, nope, you're getting that Camry. That's the best you're going to do. Sorry. And I started to think about what can we do better? So let me share this with you. This is my car. All right. I've been driving for a few more years than my son, so I can get into this car. And I love it. This was probably my favorite pandemic purchase. I bought this last year. I was really excited. It's a 2017 BMW 340i with the M Performance package. So for those of you that don't know, we're talking like 350, 360 horsepower, about equal foot-pounds of torque. The thing is a monster, right? It's fast. It'll blow the doors off of that 5.0 Mustang my son was looking at. It's a super fun car to drive, and I love the heck out of it. But you know what else? It was also a 2017 top safety pick. So not only is this car fast and fun to drive and super exciting to be behind the wheel of, it's also a safe car. If I get into a crash in this car, I can trust it to keep me safe. And so when I think about security, it's like, that's kind of what we need to be doing, right? I mean, let's think about that. Imagine our businesses want to go faster and faster. They want all the cool technology. And instead of being there telling them, no, you can't have it, we need to be the ones telling them, yes, here's how you can have it. And here's how you can be safe using it. That's what security research is all about. As all these new technologies come up, as all these new exciting applications and Internet of Things devices and whatnot come out, and we see all these new innovations, we as security, we're the ones that are trying to help them understand how can they leverage those cool new technologies in the safest way possible. That's where security lies. Because let's look at the past. Let's spend a little time with some, kind of useless, but maybe important security trivia. Do you see this guy? That's Alan Scherer. Does anyone know who Alan Scherer is? Well, let me start with this. Do you know who and what was the first password protected system? It was at MIT in 1961. In November of 1961, they released the CTSS, or the Compatible Time Sharing System. They took an IBM mainframe and said, this is silly that only one person can use it at a time. How can we set this up so multiple people can make use of it? And so they came up with this compatible time sharing system. Now, what they did was they added in controls that each user was only allowed 4 hours a day to use the system, because they still had limited resources. We can't just let everybody go all day long on this thing. And so that's how they implemented it, was they created passwords. Well, Alan Scherr decided that he wanted more than his 4 hours. And so, now remember, I said November 1961, they created this password protected system. In March of 1962, Alan Scherr figured out how to print off the password file. And he started accessing the system using other people's passwords. But he was also smart, and he distributed those user ID and password combinations to a bunch of his friends and classmates so that it was harder for them to figure out who had done this. So that's our first ever password hack, 5 months after the first password system was introduced. Now, this one you might be a little more familiar with if you didn't know the last one. This is the Morris worm. Some of you might remember this story. In November 1988, this worm was created by Robert Morris, and he released it, again, to MIT. I don't know why MIT keeps getting picked on. And the point of the worm was he exploited multiple Unix vulnerabilities and wanted to show that, hey, look, this is what I could do. And he set up this worm to self-propagate. And so what it would do, though, is it would go to each system and it would check to see if it was already there. And if it was already an infected system, it moved on. Well, he was worried that people might discover this worm and try to prevent it by having the system return a false positive to the system level checks that he was doing. So he set it up that for every 14th attempt, it would just replicate no matter what. Well, the problem was very quickly this turned into multiple infections on the same machines over and over again. Before he knew it, it was DOSing each of those machines. So that one little no forethought, that turned into the Morris worm. So that's a really popular story of kind of the first computer virus. And, now we fast forward again. We're in 2013 and then 2014. You know what happened then? The world's largest data breach to date. Yahoo was breached not once, but twice over the course of those years. They first announced it in 2016. They didn't tell us the full details until 2017, but it turns out all 3 billion of their users had their credentials exposed. So what does all this mean? How can we fight back against this? What can we do about this? Well, the security industry, for its part, has created this whole mess, right? If you're a security vendor, I apologize. I love you all, and I know that some of them are our organizers here today. I've worked for security vendors as well. There's a lot of great products, but there's so many of them because this is such a complex world. Gartner estimates that by next year, we're going to be spending over $170 billion globally on cybersecurity solutions like this. $170 billion. A few years ago, that was just over $100 billion. So we can see that it's accelerating. It's continuing to grow. We've got all these cool tools. Each one of them is kind of specialized. You see in that graphic, infrastructure security, endpoint security, managed service providers. We see messaging security, specialized threat analysis and protection, risk and compliance, identity and access management, all of those domains where we want tooling that helps us secure our systems. So how's that going? Well, if you've been watching the headlines, you know the answer. Maybe not so well. Data breaches are still in the news on a weekly basis. Now, ransomware has taken over, and especially in the last 2 years, ransomware is the #1 threat that we face in cybersecurity. Ransomware is exploiting vulnerabilities, and those vulnerabilities exist in many places. Sometimes they're technological vulnerabilities. Other times they're people vulnerabilities. We're using phishing schemes to attack users and to get them to give up details that allow for the expansion of ransomware attacks. Sometimes it's a combination of the two. But this is where security researchers come into play. This is where we have the ability to change the landscape, where we can highlight whether we're social engineers, whether we're pen testers, we're red teamers, whether we just kind of do this as our own hobby, digging into our technology and really trying to understand it is the role that we play in highlighting the security struggles that we face, sharing that information with those that create this technology, those that are using this technology, so that we can all be a little safer. A colleague of mine, Karen Elazari, gave her famous TEDx talk a number of years ago, where she talks about hackers as the immune system for the internet. We have this huge World Wide Web. Wow, there's a term we haven't heard in years, right? This huge World Wide Web of all these interconnected networks and computers and, oh my gosh, IoT devices, mobile phones, everything else that we use that now connects to Wi-Fi and connect to our networks. And they talk across the internet and they share information and they transmit information. They create all of this exciting, cool, new functionality that we have in our world. Things that we don't think we could live without. But as we've seen over and over again, with every new technology come new threats. And when you sit and listen to Karen talk, and indeed this is the reality for all of us, as that digital infrastructure becomes more and more just inherent to our way of life, it's hackers, it's security researchers, it's those of us out there on the front lines who dig into that technology with all of our creativity to really understand how it works. We're the ones that serve as the immune system. We're the ones that serve out there to identify where the infections are happening and how we can do something about it to make our world and our way of life just a little bit safer tomorrow than it is today. This is why security research is so important. So what happens? We dive in, we start digging in, we conduct our pen tests, our network assessments, we do all the different things that we do. But what do we start to discover? A few years ago, I was working at CDW. I led our information security solutions practice. And I did some research into the pen tests that we were doing out of that practice. And what I found were, when I looked at the top vulnerability themes, 40% of the vulnerabilities that we identified in the pen test for our clients were configuration management. These are things where the technology was already there to make that system safe, but because of some configuration issue, be it a public S3 bucket, an unencrypted data store, insecure encryption algorithms, passwords that weren't hashed on databases, all the things that are like simple configurations where you just flip a switch. Those were the vast majority of the vulnerabilities we are identifying. 13% more than the next closest, which was account management, and that was issues around users. So I saw this, I thought, wow, this is really interesting. I wonder how that looks historically. So I did a little more research. And look at this, look at the trend line, the dotted line here. That's the trend for what I found over the course of 3 subsequent years. 12 quarters of statistics and an absolutely flat trend line at 40%. What does this tell us? This tells us that, well, yes, the technological vulnerabilities can be an issue. It's actually our use and our knowledge of how to be safe with those technologies that becomes so crucial. So we as security researchers, we're doing as much to find, the cool 0 days in that new web-connected camera system or refrigerator. Those are great. But a lot of the time what we're finding are those common issues that businesses and consumers and organizations are making on a daily basis when they implement those technologies. And technology is constantly expanding. We're constantly looking for ways to accelerate this, make this faster and faster. What about when we look at some of that infrastructure? We have this idea of infrastructure as code, and we're letting developers be more and more responsible. And they're using things like containers to deploy. And the whole idea with containers was, well, we can use these base images, right? We can use base images. They're going to help make us safer. Well, what happens with these base images? I worked for Sneak for a while. I did the research and was responsible for writing our State of Open Source Security report in 2020. And one of the things I looked at were the number of vulnerabilities that we discovered in the latest image in Docker Hub. So these are common. These are the top most popular base images in Docker Hub for 2018 and 2019. And you can see the number of known vulnerabilities that exist. Now, you see the node image in particular is like the outlier here. Like that one's really, really bad. And that's partially because it was based on a version of Debian that, I mean, if you use Debian, you know how they are about releasing updates, and it was a very vulnerable version. But don't let those really big bars distract you from some of these others. 78 vulnerabilities in Postgres, 83 in the Nginx image, 55 even in MongoDB. Ubuntu is the only one who got really good. Like they went from 30 down to 0. So, but that could also be that it was a pretty new image, and so a lot of the vulnerabilities hadn't been discovered yet. So these are things that we're also helping as security researchers, as pen testers. These are the things we're trying to help address. But what happens when we try to bring security into the development lifecycle? How do we do that, right? So traditionally, the approach has been something like this. We have our phases of the development lifecycle. We used to call it the SDLC, right? The software development lifecycle. Then we realized, well, there's more to it and some other changes happened. So we've kind of changed. But somewhere along the way, there was this pipeline of how we develop software. Starts with the backlog, and then we get done. That's where our user stories sit, and we know all the feature requests we want. We're going to take that. We do some sprint planning, then we move into coding and committing. So now we're writing code, and we're committing it to a repository. And then we end that phase, and we move from that phase into building and testing. Now we've checked that code in. We're going to build it. Once we built it, we'll pass it off to QA, and QA is going to do all their stuff with it. Then when QA is done, and they say, hey, you're all set to go. You've promoted up through all the levels of repository, or we're ready to go to deployment. Now we go to the deployment phase, and we deploy that software, and that involves all our change management processes and everything else. And then we move into that post-deployment phase, or that monitoring phase. So when we look at that from a security perspective, our traditional approach was this. We saw those transition points between the phases of the development pipeline, and we said, well, we're just going to inject gates. We're going to put gates in here. We're going to put these quality gates. We're going to say, we're stopping you here, and you can't progress to that next phase until we open the gate and say it's okay. So maybe going from the backlog into coding, we're going to do threat modeling first. We're going to look at your whole big system diagram. We're going to create data flow diagrams. We're going to identify all the vulnerability or all the threats. We're going to classify them according to stride, and we're going to do all that stuff. And then when we get done with that, then you can start coding. Oh, and then when you get done with coding, well, now we're going to run our SAS tools, our code scans. We're going to run our, maybe we're really good at this, and we've got software composition analysis, and we're looking at that too to try to figure out, what libraries you've included that might have vulnerabilities. So, okay, we're going to do all that. And when that's all done and you've met an acceptable level of security, great, we'll move you on. And this goes on down the line. We have always done things this way in security when it came to software development. This is the story of AppSec for as long as I have been in technology. 10 years as a developer, 16 years as a security practitioner. We've always thought this way. The problem with this thinking, though, is it's so 2008. Think about that. Why am I talking about 2008? What in the world? Alyssa, what happened in 2000? What's going on with 2008? Some of you might know what happened in 2008. You see, in 2008, Andrew Schaefer and Patrick Dubois got together and had this really cool idea. They wanted to figure out, how can we remove the friction from our development processes? How can we get our developers and our operations people working together toward a shared responsibility to deploy that software? How can we make them all responsible for making sure that that development pipeline is quick? And what did they call it? They called it Devops. 2009, the first DevOps Days was hosted. That's our first understanding of the idea of DevOps. Now, we as security practitioners, it took us a few years to catch up. In 2012, Gene Kim and Josh Corman did what is kind of their now pretty famous talk at RSA, talking about security is dead, long live rugged DevOps. And it was all about this. It was all about how do we inject security? How is security as we know it completely different? How do we have to completely adjust? And yet, for years and years and years following that talk in 2012, and indeed to this day, when I go to conferences and I listen to people from security talk about how are we going to make DevOps more secure, the first thing they talk about are gates. Now, the problem with this is, look at this. This is an infinity loop. The whole point of DevOps is, and especially if we're doing CI/CD, where we're now talking like continuous integration, continuous deployment, this thing doesn't move backward, right? It moves in one direction and it just keeps flowing. It's that over and over, that repeating cycle. So what happens is when we put these gates in here, we threaten to gum up the works. We threaten to push the pipeline backward. We say if you hit this, you're moving from code and commit into build and test, and we're going to do SAST. And if our code scanners find too many vulnerabilities, we're going to push you back into coding again. We just broke that pipeline. In fact, we call it that. We call it breaking the build, right? Have you heard that term before? This is not compatible with DevOps. This is why security still kind of gets shunned from, hey, we want to be a part of your development pipeline. Let us make you more secure. And then we get worse. We get kind of almost arrogant and we say, well, yeah, you're right. DevOps is all about shared responsibility. So security is everybody's responsibility. What about our responsibility to make as part of that? If we're in security and we're saying shared responsibility, sure, they're responsible to make their software secure, but we're responsible to make their deployments faster, to make their pipelines more efficient, to make sure that when things get deployed, it's stable. That becomes our responsibility if we're going to say we want to be a part of the shared responsibility culture that is DevOps. So how do we deal with this? We got to get rid of those gates. We need to move to this model where our security practices become inherent parts of those phases in the development pipeline. We can't be the thing that pushes backward. We can't be the thing that threatens to break the pipeline. We have to be a part, integral to each of those phases, bringing tools and processes that fit right in. That's how we start to move forward. And as researchers, this is something that we can start leading the way with. So I love this study. And I know a lot of these dates are kind of a little bit old. 2020 was a bad year. We didn't get a lot of really cool research, but a lot of this stuff came up at the end of 2019. CircleCI and Puppet put together their State of DevOps report. And I love what they did here. They mapped the frequency with which we conduct certain security practices against the importance in terms of strengthening the security posture of each of those activities. So you see on the y-axis how often we conduct them. You see on the x-axis how much of an impact they have. And I know it's maybe a little hard to see on your screen, but in the upper left, we see all the traditional security things: static code analysis, pen testing, dependency checkers, security requirements. We do these a lot, but they don't have a lot of impact on security posture. Instead, when I look down here, what I see are a lot of things that talk about collaboration. Security and development teams collaborating on threat models is that one you see farthest to the right. But I also see things like security personnel reviewing and approving code changes before deployment. I see security experts evaluating automated tests. Security tools integrated into dev ecosystems. That's the big one there at the top, second farthest to the right. Bringing security to them where they live. Suddenly we start to remove the friction, we start to remove those gates, and we become a part of their process. But how do we get them to buy into this? How do we get them to accept this and to adopt this? How do we help them see? Because we all know when you talk to devs, they don't want to do security, they just want to code all day, right? Wrong. Yes, they would like to code all day, but how many of you have sat down and talked to a developer? I have yet to meet the developer who doesn't take a certain level of pride in the software that they create, in the products that they create. And they generally are kind of offended if, say, somebody breaks into that, exposes a flaw in it, because that speaks to the quality of their code. But yet, we still need to motivate them. We still want to bring that closer. So how do we start to make this happen? Well, let's start with that thing that's farthest to the right. The thing that's going to have the most impact, that thing that focuses on collaboration. It's threat modeling. Now in 2020, I do know what year it is, 15 security researchers, myself included, some other names that you might recognize if you're familiar with threat modeling, people like Adam Shostak, Izar Chandrich, Zoe Braderman. We all got together and we started talking about threat modeling. Because you see, threat modeling is this thing that we have a hard time adopting in DevOps. Developers look at it, they think of things like what I talked about before, Stride and Dread and Octave, and all these things are really heavy hitting. And we think about them in terms of this big process where we get a big architecture diagram together as part of the design cycle. And then we talk it through and we identify where data flows and where there's trust boundaries. And we try to identify all of that. And we that's a long, hard, difficult process. It ends up being that gate before we can start deploying or even start developing the software that we want. And so we wanted to figure out, how do we do this different? How do we get to a point that we can help people implement threat modeling no matter what it is that they do, no matter what paradigm they follow? How can we make this happen? And what we came up with was the Threat Modeling Manifesto. I encourage you to check this out. It's open source. You can access it at the URL there. But the big thing was, our goal was not to create yet another framework, not to create yet another methodology, but instead to inform people, how do you build a methodology that fits within your organization, that fits your current processes? And so that's what we wrote in the manifesto. Now, when I talk threat modeling, you saw already what Circle CI and Puppet found. Like, they looked at it and they said, wow, this is a thing that really impacts our security posture. And what I'm going to tell you is threat modeling is that thing that you can use to actually excite your developers, because I'm going to show you in a second how threat modeling can make the development pipeline faster. You heard me. I said it. Yes, security actually making things faster in development. Like, whoa. So here we go. We're giving them the fast car, but we're showing them how to use that fast car in a safe fashion. So we're not giving them the Mustang necessarily. We're giving them the fast car that is also the top safety pick. So what have we been talking about in AppSec for years and years and years? Probably as long as I can remember. We've been talking about this idea of pushing left. How do we get security earlier in the life cycle? Well, where's the earliest you can go with your security practice? What's the earliest point in that whole development pipeline? It's the backlog. It's the user story. So what if we simply brought threat modeling to the user story? Think about what this does for you in your DevOps world. No longer do you need a big design cycle, because you're not going to threat model the whole design of the entire system. You're going to take just that user story, and you're going to look at just the scope of that user story, and you're going to talk about the threats that are in it. Now, do I need a whole big meeting with a whole bunch of people involved? Maybe, but maybe not. Who writes your user stories most often? It's probably a business person who has a really good understanding of what the critical assets are that are involved in that user story. Maybe it's that it's a critical function that has to always be available. Maybe it's a certain kind of data that gets processed by that user story. Maybe it's something else. But they're the ones who really understand what's important to the business in terms of what that user story does. So what if we have them identify those assets, and then in plain language, forget about Stride, Octave, any of those weird frameworks we created for threat modeling that require security practitioners who've been trained in that to come in and do it. No, instead, what if they just in plain language talk about, gee, there's a threat that this particular piece of data might be stolen, or a threat that this particular piece of data might be exposed. There's a threat that, someone might try to make the system unavailable and impact this critical functionality. Put that information in the user story, because at the end of the day, the goal of threat modeling is just to give us that information so our developers understand what the threats are so they can design countermeasures to address those. So now if we put all that information into the user story, we take all that threat info, just in plain language, you put it into the user story. Now what happens when your devs take that off of the backlog and they're going to start that development? Now, it might be that you do sprint planning. Maybe you're a little more in the agile camp and you actually have formal sprint planning. Maybe you're full on CI/CD and they're just grabbing the next story, next highest priority story, and they're going to go and develop that. Either way, there's some level of planning that goes on. Maybe it's in their head, maybe it's a little more detailed. But at this point, because they have that threat information, they can take that information, they can understand the security requirements. If you're really advanced, they might even have reference architectures that they can leverage for how to implement certain security controls that would address those security requirements. Maybe not, doesn't matter. The point is you're giving them more information than they had before. Now they can take that information, and that information helps them build security controls. So it's pointed them already in the right direction. If they've got those reference architectures, they can go grab it, they can implement it, they're done. They don't even have to think about it again. If they need to build it, hey, at least they know what it is that they have to build. They don't have to worry about cycling back and forth 5 times. They can build those security controls. They can work with their security team, or maybe you even have security champions embedded in those teams that can help bring that information, help contextualize it, help them design those security controls. But then think about this for a moment. You now know what those security controls are that address those critical threats and protect those critical assets. What if we took that and say, in that developer world where we're doing infrastructure as code and things like YAML have been, really important to developers? What if we create some simple YAML language that they can take those security controls and document them in YAML and then pass that on to our QA team, who can now automate test cases that focus on and prioritize the most critical assets within that particular user story and test for the most critical, highest priority threats, making sure that those crucial security controls are working. Well, and if I can do that now in the QA in that testing process, well, can't I float that to the next phase? What about monitoring when we've deployed? As we move into that deploy and post-deploy, hand that YAML over to my SREs. Have the SREs use that to automate their monitoring. They now understand the types of threats they need to be looking for. All of this flows with a great degree of automation, and we have things prepared. Suddenly now our development pipeline gets faster. So imagine if as a security researcher, you can start to be a part of this process. Now, this doesn't replace pen testing. It doesn't replace all those other activities that we want to plug into these phases. But it helps us make what we do more integral to each of these phases rather than that gate in between. And more importantly, it starts to demonstrate how security can be valuable to the business in ways other than just some ethereal, hey, we're going to protect you from this threat or this risk, which, yeah, it sounds great to us, but at the end of the day, that's using fear, uncertainty, and doubt to try to drive people to do the things we want them to do. And you know what? That doesn't work. Why doesn't it work? Well, let me give you a little lesson in neuroscience. There's been a lot of studies in neuroscience about how motivation works. And what we found is that if I want to discourage someone from taking action, I want a child to stay away from a hot stove, I want a person who can't swim to stay out of the water. The best way to encourage that, or to discourage those actions rather, is through threats and fear. Tell that person you could drown if you go in the water. Tell that child you could burn your hand and have to go to the hospital if you touch that hot stove. That's the best way to discourage action. But we in security, we're not trying to discourage action. So when we come to the plate and we say, hey, all of these bad things are going to happen if you create bad code, that's not encouraging them to act. That's encouraging them to run away. It's a fight or flight response. And the reality is we're encouraging the flight. They're going to run away. They're going to ignore us. They don't want to listen to threats. But what neuroscience has found is that if I want to encourage action, the best thing I can do is offer some form of reward. So if I'm trying to influence people, maybe somebody whose product is got vulnerabilities that I've discovered, or users who I'm trying to influence to not click on phishing emails. Instead of threatening them with, you're going to have to go to security training if you don't do this, or, the bad guys are going to hack into your website or your app and they're going to expose all your users' data. Yes, that's important context. But that shouldn't be the message you lead with. How can you leverage that differently? To give you some idea of what neuroscience has done in this, there was a study by SUNY a number of years back, or SUNY, if you live in New York, you know that's kind of how we typically pronounce that. They looked at a hospital. They went to North Shore University Hospital. You see, North Shore was having some trouble with infections. And for anybody who's worked in the medical field, one of the most basic things that impacts infection rates in medical facilities is hand washing. Good hand washing hygiene significantly reduces the potential for infection. So North Shore University Hospital is having some problems. They want to figure out if people are washing. And so they found that their numbers were abysmal. They were about 10% compliance. So the first thing they did was they went through all this training, and they warned people about disciplinary action if you don't wash your hands, and then they installed cameras at every hand washing station. The employees knew the cameras were there. They knew the penalties if they didn't wash their hands each time they entered and left a room. The compliance didn't improve. It was still in that 10 to 15% range. So then they changed things. Now, along with the camera, they installed little signs, little marquees. And all the marquees did was, after somebody washed their hands, it popped up a message, said, way to go, or, some kind of encouraging message, said, good for you, thanks for remembering to wash your hands, whatever. That little bit of encouragement increased their numbers from 15% compliance to over 90%. It's uncanny, just that little reward. So how can we use that in security? How can we do that same thing to get those kinds of numbers? This is where the BESO can help you. So if you read the abstract for this keynote, I told you I was going to talk about the BESO because I'm a BESO. And I think that my role is particularly valuable. And I think we as security researchers want to start thinking like a BESO as we try to influence those businesses that we're working with every day. So let's start with, what the heck is a BESO? So typically in most organizations, you might be familiar with this. You've got a business line over here, you've got the information security team here, and you have this cavernous divide between the two. They don't like to talk to each other. They're adversarial in their relationships. It's just not a friendly thing. So what does the BESO do? The BESO comes in and builds a bridge between the two. Now the BESO, unlike a CISO, is not a separate organization. As the Business Information Security Officer, I don't report to the CISO. I actually report into the business. I am part of a division. I lead the security strategy for our entire division, and I report to the divisional CTO. Now, why is that important? Because that bridge needs to be two ways. It's not just about advocating within the business that they do security things. It's also about advocating on the part of the business when I talk to the security team. How do we get security initiatives to align with what the business is doing? How do I demonstrate how this security initiative is going to be of value to the business? Because here at the end of the day, when you stop talking in security terms, when you stop talking in terms of FUD and threats and risk management and focus on the things that matter to the business, and you connect what you're doing from a security perspective or what you want them to do from a security perspective to the priorities of the business itself, suddenly you get more traction. So how do we start thinking like a BESO? Well, we have to think about those motivations. What do they care about most? The first is profitability, of course. So how can your security steps, how can your security practices, how can your security initiatives help make them more profitable? How can it save them money? Look for the ways that it can do that and present those. Present what you're asking them to do from a security perspective in light of how it's going to save them money. Or how is it going to help them in terms of innovation? How is it going to make them able to leverage new technologies in a safe way to build a fast car that's also safe? Show them that. Bring that context to your discoveries, to the things that you're seeing, to what you want to influence them to do. And then there's this whole idea of agility. How do we make sure that our products are agile, that we can move quick, we can leverage our DevOps and CI/CD pipelines, our product development to be faster and to respond to our user needs? And how does security enable that? I showed you one example. But think about in terms of how does this thing I'm asking you to do, how's that going to make you more agile, make your products better, enable you to bring them to market faster? And speaking of the market, how can you use that security as a competitive advantage? How does it improve your overall position in the market? How does it make your business model more sustainable? When we focus on these things as we talk to people who are not security practitioners and researchers, this is how we motivate them. Speak about your security ideas, those remediations in terms of their motivations. Give them that reward, that carrot. Put it out there. Hey, you can do this if you do this. Or doing this security thing will make you able to leverage this technology faster, quicker, safer. Focus on those elements and bring that message to the table. That's what we need to be doing. That's the future of security research. We can't just talk about the security technical jargon anymore. We have to understand that if we actually want to share information, we need to share it in a way that's meaningful to the people that we're trying to convey that information to. So it's just about time for me to wrap up. I'm going to leave you with this quote. This quote is from John C. Maxwell. He says, "Nobody can motivate themselves in a positive direction by continually using negative words." So stop talking about the FUD. Stop talking about the horribly bad, awful things that are going to happen. Let's talk about the good that will come from those security practices that we're advocating. Let's talk about things that are exciting to the business. Let's look for the ways to give them a fast car that will also keep them safe. They don't need the Mustang. They don't need the Camry. Get them into that super fun, super exciting, super awesome car that also is going to protect them when things go wrong. Finally, I invite all of you, continue the conversation. Reach out to me on social media. I'm always happy to talk about your ideas, share more with you about what this weird thing is that I do. It's called a BESO. I do other talks on that. You can go to my website. You can see those talks. You can contact me there. My blog is there, so I've got some information there too about the role. All of these ideas you're hearing about are things that I talk about all the time. So I invite you to check that out. Check me out on LinkedIn. Twitter is by far the easiest way to get in touch with me, though. I'm more active on Twitter than any of these other things. So by far, I invite you to join me there. And then finally, great big thank you. Thank you to all the organizers for the Intent Summit. Big thank you to my employer, S&P Global Ratings, for making it possible for me to even be here today. And most importantly, thank all of you for tuning in, for being a part of the summit. Remember everything we've talked about as you go through the rest of this day and you hear all the various talks, all the different ideas, all the different technologies that you're going to hear about today, all the different research and all the exciting stuff that we're doing with technology. Remember in each of those moments to think about, all right, how do I show this in terms of the fast car that's also safe? Thank you so much. Take care, and we'll see you all again real soon.